Yeah, so let's keep the conversation going with geothermal technologies. We're going to bring up Sam Casamano now. He's a licensed engineer and also a lead accredited professional with over 18 years of experience designing mechanical systems for buildings. Sam was raised and educated in the Utica area, where he received a BS in mechanical engineering from SUNY IT. He began his career at Town Engineering in Utica, where he remained for about 15 years before co-founding IPD Engineering in 2009. IPD now employs 16 people, provides plumbing, fire protection, HVAC, and electrical design services. Sam's passion has been and continues to be pushing the limits of efficiency, providing value to his customers. Sam?
To get out of the way, I'm older than I look. I have a question whether I should even be up here because this is already been talked about.
Louder, please.
So the pipe block project is something that, as you've heard, the IHG started a few years ago. And it involves 4 historic buildings in downtown Syracuse at the intersection of South Line and West Fayette. So we've got the Bond, Wilson, Witherell, and the Chamberlain buildings that make up this project. It's roughly 150,000 square feet of building altogether, and the premise is we're going to create residential apartments in the upper floors, commercial space on the lowest floor. We've got several residential apartments already rented. People are in their apartments now. Center State CEO will actually be taking part of the first floor. That was a surprise to us. We had to change some things on the fly. In the ground floor, we have a few times Tim Hortons, Pathfinder Bank, Jimmy John's Sandwich Shop. So we're on our way. I'm going to talk a little bit about what we've done in the building for it to be green. Some of the initiatives that we have done, at least from a mechanical electrical standpoint, include energy recovery on the ventilation and exhaust systems. We're using a solar thermal array, which is kind of like what you see here, to make domestic hot water. We're using a Dayton VRV system for HVAC in the residential spaces, and actually that was the plan for the entire building until I talked to Peter Kahn, who introduced me to the Brine Aquifer. I researched it, went to see Bill, actually took with us a guy by the name of Ryan Bay, who's with American Auger, the company that drilled our wells. Ryan unfortunately was in a snowmobile accident and died this past winter. So that was one of it. But we all went to see Bill, we learned about this, and it seemed to make a lot of sense, so I brought it back to my partner, Dave Nutting, asked him if he was interested, and Dave wants this building to be as cool as it can make it, so he was like, go for it. So we're off and running with the central open loop geothermal system. And open loop, as I think you've already heard here, is kind of abnormal for the upstate and central New York area. Geothermal is typically done with closed loop well systems, where a lot of schools do this, or you need a football field-sized field. You're drilling lots of wells, in some cases 100 to 150 wells. With open loop systems, you can do much less wells. The wells actually don't cost much more on a per well basis, but it's more risky. You're not exactly sure what's going to come out of that well on day one or down the road. Dave is risk tolerant, so he was willing to explore. Some other things, we're doing some rainwater collection. Save the Rain programs helped us with that, and we will probably be adding some PV to the building eventually. So you've already seen this, but I'll go through it again. This is basically what's happening in our geothermal system. Now, there's a little bit of complexity due to the brine in the ground. This would be super simple if it was a freshwater system. Basically, it would be, we would pull water out of the ground, send it directly through our heat pumps, and right back to the ground. It would be that simple, that straightforward. The only issue would be getting the EPA to give us a permit because of the potable supply of water. The EPA, as you've already heard, has given us approval for this project. We got response from them in only 2 or 3 weeks. I was amazed about that. What happens here is we extract brine from a well that is only about 90 feet deep. We found when we drilled our test well, which is one of these two, that water or brine was present about 24 feet below the surface. We started pumping it, and it pumped down to about 35 feet below the surface where it held. So it's a very plentiful aquifer in our area. We pull the brine out. I'm showing a pump at the top of the well. It's actually in the well, at the bottom of the well. And we have it wired through a variable speed drive, which I'll explain in a minute. So we pump the brine out, put it to a plate and frame heat exchanger. Now, this is what makes our system a little bit more complicated than it would be if it were a freshwater system. We had to buy titanium plate heat exchangers. We actually bought 2 of them, just in case one gets fouled, we can switch over to the other. These are coming from Sweden. This is going to be the last piece of the puzzle when we actually get this thing up and running. It's going to be at the end of next month. The plate and frame heat exchanger consists of 80 to 100 plates that are very thin, very close together. On one side of each plate there's the brine, on the other side there's the water for the heat pump. This device allows us to keep the brine and the water very close in terms of their temperatures, only 1 or 2 degrees apart from each other. So a lot of heat transfer can happen in a plate frame heat exchanger. Brine comes up, comes out, gets pushed back into our reinjection wells. On the other side, the water just flows around in a circle through the heat pumps. So I talked about there being a variable speed drive on this pump. The idea there is I don't want to be pumping as much brine as I can be. I want to pump as little as I can to meet the load. So as the load in the building from the heat pumps rises and falls, I'm varying the speed of my pump to meet the needs of the building. What else can I say about this? The temperatures have already been talked about a little bit. I'm showing the ground is about 50 degrees. It varies between 50 and 60 degrees. We pull it out at that temperature. What I put back in is only 10, up to about 10 degrees warmer or cooler, depending on the time of the year, whether I'm heating or cooling the building. And, at the site, we have Salina Street, a sidewalk, and below the sidewalk is a vault, an existing vault. The vault is open to the basement of our building. So we decided to put our extraction well where the pump will be at this location. So we cut a hole in the sidewalk, got all kinds of permits to do this, cut a hole in the sidewalk, and we put our drill rig here on the sidewalk and we drill down. So now the idea is if we ever need to get out our pump, we can pull through the access cover that we created. This is a site plan showing our site. The buildings are here. Okay, this shows our 3 wells. So we've got our extraction well here on Salina. This was our test well. The reason it was our test well is it was on our property. We had to get a minimal amount of approvals to do the test well. And when we did the test well, we only drilled an 8-inch bore hole. We used a 6-inch sleeve. When we did our testing and went to Brine Aquifer for their input, we decided to go with a larger bore. So we went with a 1-foot diameter bore, and we used an 8-inch screen, all PVC, so that we wouldn't have to deal with the corrosion issues. Our second reinjection well is located in the sidewalk on South Clifton Street. So you have a 200 feet separation here and a 300 feet separation here. As it turns out, you can pull more water out of one of these wells than you can put back in. So we have a need for 2. There's several reasons for that. I won't go into it. So just my last slide here is just showing you some pictures of the drilling. The two on the left are our test well, so this is in the courtyard. And pictures off to the right are in the Salina Street location. So looking down from inside the building from up above. This is actually the vault. So we were drilling from up here, and what we did was we put a casing in so that the stuff we pull out of the ground doesn't fill the basement. It got pulled through the casing and out onto the trucks that are right there, as you see. So I'll be open for questions at the end. Turn it back.